In this video tutorial, you're going to learn about the more advanced features available to you in Planit for your Milky Way planning. Hey everyone, this is Mike Shaw with Planit for Photographers. In particular, you're going to see how you can change your mindset from passively checking to see what the Milky Way might look like on a particular night to a proactive mindset in which you actively seek dates in the future when your chosen composition is possible. And here's a couple of examples that might help explain this context, even though they're not related specifically to photographer. So back in the day, our ancestors would gather fruits and vegetables to eat as they ripened. But at the end of the growing season, they had to learn how to preserve them for the long, cold winter months. Also, once they discovered how delicious meat can be when it's cooked over a fire, they had to learn how to create the fire themselves in order to be able to do so whenever they wanted. The point being is that in both of these cases, they had to learn how to take control of their situation to tailor their circumstances to their needs. Now, in many ways, landscape photography isn't much different. When we first started to learn landscape photography, we'd just go out and shoot whatever is available that we'd see. But as you go along, you learn how to use your creativity to create unique shooting opportunities for yourself and bring your photography to a new level. In this way, you kind of become a photography hunter. And this mindset is especially useful for Milky Way photos, since many of us live in places such as a city or a town where we can't even see the Milky Way at night. And this means we just don't have many opportunities to practice, so it becomes even more important to have a reliable plan to have good success. All right, so to begin with, let's switch to the Milky Way Seeker page like this. And we'll set the camera location to be the same Mount Everest Base Camp location in Tibet as in the Milky Way Center video. And for the same date, May 9th, 2019. Next, let's point the green fan to Mount Everest, and then go to the VR viewfinder, and we'll also change to a 35mm focal length lens right just here. Okay, so right here, this is Mount Everest. It looks like a little triangle. Now, let's say that this is the foreground composition we like, and the question is, what kind of Milky Way can we add to this composition? And as you saw in the Milky Way Center video tutorial, the easiest way is to just adjust the time slider like this. And as you can see, as the slider is adjusted, you can see the Milky Way moving through the view. This green band, of course, is the Milky Way, and you can see it rises higher and higher until it eventually moves out of the frame. And of course, if we change to a 16mm focal length lens, you can see that it stays in the frame for a longer time. So in fact, from this point here, all the way over to this point here, that's the range of all the possible compositions that include both Mount Everest and the Milky Way in the same frame. Now, check this out. In this particular tool, the Milky Way Seeker tool, you can now actually tap this button right here to see all the possible Milky Way compositions. And each one has a slightly different configuration. But the problem here is that you don't know how each precise composition relates to the foreground, so it's hard to know right here which one's the best. And although the Milky Way center elevation angle and azimuth are shown right just here, there isn't the same visual representation as in the VR viewfinder. But hey, it doesn't really hurt anything if we just try one out. So just for example, let's pick the Milky Way arch at 50 degrees. And as you can see, this is what it looks like. Or we can go back and pick 20 degrees. And this is the composition of the Milky Way arch at 20 degrees. Not so great. But note, once you become familiar with these compositions in terms of degrees, you can then jump directly to the one that you want instead of having to adjust the time slider. So now, to make it simple in this example, let's choose a 50 degrees Milky Way arch and a focal length of 35mm. So now, this is the composition that we want to capture, and this is where we start hunting. Remember, we want to find dates in the future when this composition is possible. So to do that, let's pick the 2019 calendar year from January 1st, 2019 all the way to December 31st, 2019, just like this. So now, check this out. This tool is going to go hunting and it's going to capture all the dates during the entire 2019 year when this composition is possible. And look, right here they are, all of them. There's quite a few. And for each of them, the Milky Way is going to be at the exact position as shown right here. And right there, you've changed your mindset into a proactive Milky Way hunter. Okay, so let's just take a step back for a minute. It's easy to get a little confused right just here. And let's go over a little bit of background. Now, you may remember that the Milky Way actually moves around the Earth every day, just like the stars and the sun and the moon. Well, of course, more precisely, it appears to move because of the Earth's rotation. So now, how long does it take to rotate 360 degrees in the sky? You might think 24 hours, of course, but it's actually about 23 hours and 56 minutes. But practically speaking, if you see the Milky Way at a certain position in the sky at 8 p.m. today, tomorrow it'll be at the exact same position 4 minutes earlier. In other words, at 7:56 p.m. instead of at 8 p.m. And this is what we call the sidereal day of 23 hours and 56 minutes, which is different from the solar day of 24 hours. The sidereal day most accurately describes the Milky Way movement, so the Milky Way will repeat itself every day except 4 minutes earlier every day. Okay, but then why can we only see the Milky Way at this particular position only 128 days out of 365 days? The quick answer is because during the other days, although the Milky Way is certainly there, it's there during daytime and we can't see it. So the results that you see here are all at night. And you may remember that night is defined as whenever the sun is below 18 or more degrees below the horizon. This is when the sky is dark enough to see the Milky Way. Okay, so let's click on these results and have a look. You can see the sun elevation in this column in the list. And all the elevations are in fact less than 18 degrees, just like we said. Now for the moon, the situation is different. For some of the results, the moon is up, but for others, the moon is down. So you want to be able to select or filter out the particular moon situation that you want. And this brings us to one of the most important features in the Milky Way Seeker, and that is the filter feature, right here with all of these possible filters. We'll start with a simple one first, the last one being on the filter section are the weekdays. And this is for people who need to work during the week. In these cases, you may filter by weekends and to do this, you just choose Saturday and Sunday like this. And now when you check out the number of results up here, you can see that the number has been greatly decreased. But if you can go any day of the week, then you don't need to worry about this filter and you can remove it. Okay, so the first set of the filters in the list are for the moon phases. And if you want to shoot the Milky Way with a small rock nearby in the foreground, for example, someone that you can light up with a flashlight, then you don't need to depend on the moon to illuminate the foreground. And in this case, you may choose no moon. And in this way, the Milky Way will be as bright as possible. However, if the foreground is huge, then there's no way you can light it up with an artificial light, for example, like Mount Everest. Then without the moon to light it up, it won't be a great photo since the moon will be too dark and it will just be a silhouette. So in this case, we probably want to choose a night that does have a moon to light up the mountain. In this case, the moon position filter is going to be useful. And the first one of these filters takes out only those cases when the moon is in the opposite direction of the Milky Way center, plus or minus 6 degrees elevation. It basically means the moon's at the horizon. And now we see only very few results. But why would we want to use this filter? Well, when the moon's on the opposite direction of the Milky Way center, it's going to act like a light that lights up the mountain. So if we look at these few results here, we can see this one right here looks pretty good. The moon elevation is shown right here. And it's also a relatively bright moon, as you can see here. So it should be able to act like a nice bright light. Okay, so now we want to check out the results on the map. And the moon is right over here. Milky Way center is right over here. So the moon is going to, in fact, shine on the mountains from behind just like we wanted. And as we mentioned in the earlier Milky Way video, moonlight from a low-angle moon can light up the mountains in the most beautiful color that's red. And you can imagine that composition of the Milky Way center with a beautifully red-lit mountain. That should be an awesome photograph. Okay, so now for a second thought, maybe we want the Milky Way center to be lower. For example, in this position right here, a little bit closer to Mount Everest. And this way we can use a 50 millimeter focal length lens. And that's going to allow us to capture more details like this. And now if we go back to the result list and check it again on this date, the moon is too bright, which might not be good for the Milky Way shots. However, keep in mind that when the moon gets low down to next to the horizon, its brightness is going to be reduced significantly. And this means that you may get a better red color on the mountain than with a less full, dimmer moon. And that's the beauty of planning, right just there. You get to choose between a redder peaks versus a brighter Milky Way. Totally up to you. Now the second button down here for the moon position is again in the opposite direction, but at a higher altitude, more in the 6 to 12 degree range. And we might choose this if maybe there's some high elevation mountains behind us, in which case the moonlight going to have a tough time to reach the foreground, and to do so the moon needs to be higher in the sky. And that's why we include this filter. So for example, in the case of Mount Everest, we don't really need it because it's so high, tallest one in the world. No other mountain can block it from being lit up by the moon. Okay. Now, the next three buttons are for the moon in the same direction as the Milky Way. For the case we were just talking about, remember, it was in the opposite direction. Now, when it's in the same direction as the Milky Way, we don't depend on the moon to light up the foreground. Instead, we want to include the moon as a part of the composition itself. Okay, so let's select the same direction, plus or minus 6 degrees as an example. And again, we'll select a 50-degree Milky Way arch. And we'll use a 35 millimeter focal length lens. And now we can just see a few results, but among these, none of them are particularly useful, and the reason being that there are mountains blocking the moon. And so let's just pick one of them so what you can see. So let's see where the moon is. Maybe we'll switch to a wider angle lens. Okay. And as you can see right over here, while the Milky Way center is here, the moon is all the way down here. These foreground mountains on the left block the moon. And so what this means is that if we select the moon elevation angle to be between minus 6 and 6 degrees from this location, chances are we won't be able to see it. Okay, so which filter do we use? Let's try 12 to 24 degrees. That should put the moon higher in the sky. Let's see if that'll work. So for example, let's select this date in April. And the moon is right here, which is visible, so that should work just fine. What about the results before this date? Let's check this one in March. And as we can see, it should work just fine too. Now, in the case of the moon lighting up the foreground when it's behind us, we may want to have a bigger moon, a more gibbous moon. But here, when we have the moon as part of the foreground, we want it to be a dimmer, more crescent moon. And as you can see, among all the results here, the last few results are not good since the moon is gibbous and very bright. In fact, the ones that we want are the first few in the first half of the year. This one here in March looks pretty good. The moon just shows up above the mountains. Let's have a look. And that looks pretty good. All right, so that's about it for the filter for the moon in the same direction as the Milky Way. And we also include a moon above the head or overhead moon filter. This is useful when the foreground is a canyon or a valley. If the moon is too low, the valley is going to be too dark. In this case, you might want to have the moon really high in order to light up the interior of the valley or the canyon. And the last set of filters deals with the angular distance between the moon and the Milky Way center. The last value of greater than 48 degrees, it's easy to understand. The further away the moon is from the Milky Way center, the brighter the Milky Way center will be. So this filter is to make sure the moon is far enough away. Consequently, if we choose greater than 48 degrees, it means that we want the moon to be far away from the Milky Way center. But photographers like to challenge themselves. The harder it is, the more challenging it is for the photographer. A good example is when the moon is close to the Milky Way center or even within the Milky Way center, and that's what the rest of these filters are for. So, for example, if you select the moon to be less than 12 degrees angular distance away from the Milky Way center, then we would suggest that you also add a moon filter to include only the 2 crescent moons. Since really these are dim enough not to drown out the Milky Way center. Now in this example, we don't see any results, but in some other compositions it might be possible. So let's adjust the time and see what we can find. And here we go. Here's a result. Here you can see the moon is near the Milky Way center, and you can see it right just here. So now if we go and choose a longer lens, say 50 millimeters, The Milky Way center is here, the moon is here, and it's also a crescent moon. We actually want the moon to be small, the smaller the better, because even a very dim crescent moon with a Milky Way dark sky will significantly change the composition and the feeling of the final photo. So that's how these photos work. The other two filters are just two choices for you, so you can choose how close the moon is to the Milky Way center. And that's it for the Milky Way set, and that's it for the Milky Way Seeker tool. And finally, let's have a look at this great photograph here. This shows the Milky Way and the moon at the spot we've been talking about, the base camp of Mount Everest in Tibet, taken by Weibing Liang. He used Planit to figure out a good time to go there and capture both at the same time. So until next time, this is Mike Shaw with Planit for Photographers saying thanks for watching, and we hope you enjoy hunting your Milky Way shots with the Milky Way Seeker and Planit.